Well, I felt bad for only having done a quick video there on the last one, so I'm going to give you another one. Not only that, I haven't done one in a while, so thought I'd make up for it. I had a student come to me the other day asking questions on, she was having some trouble with sine, cosine, and tangent, and shifting and stretching and lifting and moving of the graph all over the place. So she had a quiz coming up. I decided, let me show you with some color here. So I pulled out the prism. Let me show you what I showed her here. Typed in two things. Typed in the sine of x. And I also cheated a little on typing in the second one here. If you go into Tools, into Built-in, notice there's the sine. Now, I wanted to see the phase shift, and I also wanted to see the shift up and down, so I had a D. So let me exit. So on that blue graph, I have an extra set of parentheses there. That allows me to see the phase shift. How much did it shift left or right? Where is it starting? And also how much did it shift up and down? So when I showed her, I said, all right, let's take a look at the window here. We're going to say, you know what? We're going from 0 to 2 pi. In increments, the scale right there is pi over 4. And going from -5 to 5. All right, so let me exit back out one more. I'm going to use the modify feature. The modify feature is going to let me change one of these at a time. So there's the blue graph. There's a red graph, one on top of the other. I said, all right, well, let's see what happens. I'm going to start increasing A. The original one was on the yellow. It showed real quick. The red hides it. So what happened? The wave got 2 bigger. Wave got 3 bigger. Wave got 4 bigger. So nothing else is changing about the wave. The wave is still crossing at the normal places. The only thing that's changing is how tall it is. So let me go back to 1. Gets me back to my parent function. All right, now let's take a look at B. Start increasing B. Oh, look at that. Twice as many waves. Looks like 1, 2, 3 times as many waves. 4 times as many waves. 5 times. 6 times, because here's 1, 2, 3, 4, 5, 6 times the waves. One more. 7 times the waves. 1, 2, 3, 4, 5, 6, 7. So she got the pattern on that one pretty quick. I'll go back to 1. All right, now let's see. Increase C by 1. Increase C by 2. Starting to see that there's a little bit of a shift. So if C is 2, it's shifting back 2. To get a better idea, let's put in something like pi, for example. So I'm going to put in pi for that value. Oops, don't want E, I want pi, so shift. Shift, there you go. So now I've been shifted over by a whole pi there. And in fact, I could actually do it in increments of pi over 2. So if I go to step here, we go increments of pi over 2. So then when I come back up here, I'm going to start back at 0. Now watch happens when I start shifting by pi over 2. And which way is it going? So now what happens there? What happens there? Now these are shifts of pi over 2. Well, again, she figured that out pretty quick. And finally, D. I change my step back to 1. And I'm going to go to D, and I'm going to increase D. And what happened? And what happened? What happened? All right, what if I go negative? Let's go -2. Again, notice what's happening. Shifting up, shifting down. And then the last one I threw her was one where I said, okay, what happens if A is negative? Let's go with negative 2. And B is negative 2. And how do those change and how do they cancel out? So again, she got the point pretty quickly. This is a great tool for teaching. And a final thing I love to do with students is to do something along the lines of you play the little guessing game. Now that you think you know what's going on, you put in the secret graph to sine of parentheses 3 parentheses x minus pi over 2 close the parentheses. Oops, close them too soon. Close them there. Close the blue. And I'm going to subtract 2. And then I will draw. All right, now the student will have to look at this green graph because I don't show them when the thing is graphing them. I show them the green graph. I said, okay, you have to make your blue graph match that green graph. And you get 3 tries. And they write down what their guesses are and they put them in and see what happens. So this is a great way to teach transformation of functions because you get to define the parent function in red and students see the original parent function, which is very important. You get to see the changes when I did the modify. That's my blue graph. And finally, you get to challenge them with something like, okay, now you have to match the green graph. So all in one screen, all in one nice place. Great teaching tool. The lesson library is now open and ready to accept lessons, or if you want lessons to go borrow, feel free to go on Casio Education. There's lots of lessons out there for you to try out. Let us know what you think. Thanks.